thank the organizers for giving me this stage and this wonderful presentation. And just to remind everybody that I'm talking about how to fine-tune or specialize LLM models for a more academic setting with the KCD. As was previously mentioned, I work at EMBL, that I'm part of the DKCD group, and we are focused on trying to help people use cloud computing, cloud storage, and receive training to use cloud computing technologies. So this fine-tuning an LLM is a specific use case of the use of cloud computing, cloud storage. So feel free to contact me for any support regarding cloud computing and cloud storage. Now, let's begin with a little motivation. This, by the way, is a document that will share, and it has quite a few links and some instructions because the intention of this presentation is to be kind of hands-on. So we're going to go to places and do things. Hopefully, you might be able to do the same kind of thing at your own pace with the video. So let's start with why fine-tuning. So LLM models like ChatGPT, most people already know them, and they're very good at doing a lot of general tasks. But sometimes we might have a more specific task that an LLM could also do. For example, if we gave an LLM and asked them to generate a set of keywords from a document, it might be able to do that. But if you wanted to limit the keywords to a certain defined vocabulary, then it might be more challenging. And also, these general LLMs tend to be very large and hard to run on a lot of infrastructure. Smaller LLMs that can be fine-tuned based on these bigger LLMs can perform very well for specified tasks. Fine-tuning basically sacrifices the general performance to do anything for more specialized performance that we might have clearly defined. Unfortunately, if we fine-tune a smaller model, which will likely perform faster and also better than a generalized larger model, if we don't train it correctly, it might collapse in knowledge. It loses the structure of its patterns internally. So we have to be careful on how you fine-tune an LLM to not lose the general performance. As I mentioned, smaller models are faster and easier to provision, as in there's more hardware accessible that will run a smaller model as compared to larger models. So if you have a clear task that has good quality data, that where you have an input and an output that's clearly defined and expected, and you might have a set of example data, this is a great basis for thinking I might want to have a specialized LLM, a fine-tuned LLM that runs maybe locally or on the premises in your institute, or possibly with the support of the KCD in the cloud computing environment that the KCD helps provide. When we at the KCD provide this support, the data is private and secure, and we have a direct contact with the user of these systems to try to establish the system as requested by the user. This is in contrast with more commercially available platforms that might not be so open to adjusting themselves to the needs of an academic environment or other environments. So with that, just let me say that feel free to contact me, and especially if you have some example data where you have a clearly defined task with some input and some output that you've already validated, And maybe you try to fine-tune an LLM model yourself and came into some issues, your experience in general, I would be very happy to hear about that. So feel free to drop me a mail if you'd like to. So now, we're going to go through quite a bit of material, so we're going to go relatively quickly. I'm going to explain the outline, and in the outline, we have a lot of information already. After the outline, we'll go into more hands-on. So the outline is basically a discussion about a task that we want to achieve. The toy example that we have is, I want to easily get keywords for digital objects, like lab notes or a data set. I would also like to automatically get as much metadata as possible. Some of this metadata might be within some controlled vocabulary. Uh, and also eventually, maybe it would be nice to find links within the different digital objects. I mentioned this of linking digital objects because when you have a large collection of data that you might not want to share to the public, an LLM that runs locally might be a good task for um, this type of task. So we'll start with something called in-shot prompting. Basically, we're not fine-tuning, we're doing the first stages of what would be fine-tuning. So let's imagine that I have this video of NFDI4DataScience, but I'm only interested in a certain part of that video. So I can use a tool like Notebook LM to transcribe the video and navigate through the content of the video to find a particular part of the video that I'm interested in. I already went to Notebook LM and did this, but what you could do is in Notebook LM, create a new notebook, and here where it says YouTube, link the video. You could also add other types of sources like Google Docs or text or files in these formats that could be included. So for example, if I, whoops, copy that link and add it as a YouTube video, I can see that in the background, it already made a transcript, and down here, it can generate a mind map. With the mind map, I can navigate to, oops, the different sections of the document, of the video, or the transcript of the video. In this case, I'm going to choose this metadata standard, and I get a summary of that information. I can save these as a note or copy them into a separate document. I will copy this, oops, and put it into a new document. So I do that because if I can keep some of the formatting of the document instead of copy pasting it, and that gives some additional information. So once I have this, what I'm calling a digital object, which is this note that I extracted from a video, from the transcript of the video, I can just simply go to a system like in Notebook LM and ask to get keywords for this. I'm going to go back to a more simplified view. And I'm simply going to type in, please generate keywords for this. And it can go ahead and start to generate a set of keywords. But it turns out that maybe these are way too many. What I would like is to have a fewer set. I need a prompt, which is what I write here, to ask for something more specific. So I'm going to go to Perplexity AI and ask the LLM to write a prompt for me. Please write a prompt to generate a list of keywords from a document. And I can read and review this prompt. And I noticed that it has no limitations on how many examples to give. I'm going to ask it to make it 3 to 6 keywords. So I can use an LLM to help me define the prompt to achieve the task that I'm interested in. Now, I have a more well-defined list of data, of keywords for this document. And that was pretty straightforward. What if I wanted to generate uh, when, sorry, one of the things that you can do in the prompt is give it some set of examples to tell it what you're expecting to receive. So when I told it that I wanted only 3 to 6 keywords, it understood that it needed to refine its search. And if you give it examples, this is called in-shot prompting. But let's say that you want to do this same type of activity, but for many documents. So it would be cumbersome to go into each document and add this prompt for each document, the prompt of generating those keywords for a document. So what you can do is go one level up. This is called the system prompt. This is basically the same as the user prompt, what the user asks for when they're chatting with an LLM, what you write over here. But the system prompt differs because it's based on what the developer wants the system to have, what the developer wants to prompt. So for example, here I have the document, once again, my digital object, and in the system prompt, I told it to generate these keywords. By the way, in this case, I'm using Chat AI from Academic Cloud because it gives me access to this system prompt, which is what developers, the instructions that developers would suggest to use. Not only does it give me access to this system prompt, it also gives me access to other properties of the LLM. And also it gives me access to any other models. So I can test the performance of different LLMs. So now, if I have this system prompt and I give it this digital object, this file that I mentioned before, without, oh, giving it any additional instructions, but the system prompt one that's already there, it generates the list of keywords. And here, I could also compare how it would perform with other models. For example, DeepSeek R1. I will rerun this, and we can see that DeepSeek R1 generates a response in a different characteristics. It's a little slower because it's a larger model, and it's more verbose. It generates more text, but at the end, it has a similar result. This is an indication that a smaller model might be well suited for this task. So we can see that if we use the system prompt, whatever document that we provide to it, it'll do that same instruction. I'm looking for a different document now. This is the initial summary. And I'm going to go to Chat AI to provide just some other document, in this case, just copy pasting a text. And I don't need to provide any additional information because the LLM is taking its instructions from the system prompt. By the way, one key aspect to note here in, for example, this distill model is that at the end for the distill, for this, I receive just a list of the keywords. But to be honest, LLMs, their way of processing information is through tokens. What that means is that they need to generate a larger result in order to think about the material more. In reasoning models like DeepSeek that we just saw, this thinking process happens in the background and it generates the final result separately. But most models are not like that. I'm going to run this again using a different model, and you can see that it generates more text because it uses this text to think about the task. This is also true for the system prompt. What I'm trying to say here is that you can imagine that the more words, the more clearly you can describe the task with more words, you give a better opportunity to the LLM to perform well. So we just saw that we did the system prompt with Chat AI Academic Cloud. We tried it on different models of different sizes. For example, Llama 8B compared to 70B compared to DeepSeek, where we noticed that some had a longer duration. The DeepSeek takes longer, or the 70B model, which is larger, takes longer to process, but they generate the same type of result. It's good to keep track of the results, this validation set, when you experiment with different models to see which ones are actually performing well. Different models will perform differently. Now, here I was inputting each digital object individually, but what if we had a RAG system? RAG basically means that I'm providing the documents that I'm interested in as files separately, and the LLM processes them to find the documents in the background. I don't have to copy paste, basically. Here, if I had this file and I saved it as a text file, I could have files that I could upload, for example, to Chat AI. Chat AI's RAG system, this where to upload its files, is called Arcana. This is very similar to other LLMs where you can, for example, attach files so that the file that we generated is added into this context, the LLM's context. So I don't need to copy paste any text. It just accesses the file. Please generate keywords. As you can see, it read the file in the background. That's the basis of RAG, providing it your own information. For NFDI, for chat AI, it's called Arcana. I can generate a new Arcana. In this case, you click here. I have this data collection. It has that I uploaded this file that I just downloaded from Google Docs. And then here you have to notice there's this one thing that's called index. So to understand a little bit about index, internally, an LLM represents text in little parts called tokens. Now, those tokens are not actual text, they're more like numbers. And these numbers kind of have a semantic meaning. What do I mean by that? If you had a token like king, which is represented by some number, actually a vector, a collection of many numbers, thousands of numbers representing one token, which is part of one word. If I had the token king, subtracted male, and added female to those numbers that represents these words, at the end, I would be in a location very close to the word queen, because there's some semantic meaning encapsulated in this token vector. So to convert our documents into this numeric format, this tokenized format, embedding it's called because it's a long list of numbers, embedding our document, we have to index it, convert it into this semantic meaning so that the LLM would be able to better understand what's inside that content. In this case, we can just click generate the vector database for Arcana. We can index the document, and here there's a short explanation if you want to hear more about it, about the embeddings. Once we do that, the LLM now has access to these files. And if I click on access link, I can chat with my Arcana, chat with my collection of documents by clicking access link. Now I have this Arcana saved for me. So if I give it the system prompt that I had before with this Arcana, I can try and ask it to generate the keywords for the documents you have access to. Unfortunately, this is not going to work. I'm not sure why, but what I do know is that there are other systems that do have this RAG functionality enabled. And in fact, one thing that you have to keep in mind that I often forget here is that you have to find a model that's able to retrieve the Arcana, and you recognize them by this little book icon. So if I run the query again, generate the keywords for the documents you have access to, I still have that same issue. But now that I understand the concept of RAG, which is uploading my files and putting them in a vector embedding format so the LLM can access it, I could run this as code. Here's a very nice example from Robert Haase at Scott's AI, where he gives a Jupyter notebook using RAG, Retrieval Augmented Generation. Now, I can't run this notebook here, but if you needed support for running a notebook like this, we at the AKCD would provide you a Jupyter notebook environment that would enable you to run this type of workload. So you wouldn't need to share your data to other providers, especially external commercial providers or maybe ones that are not within Europe. By the way, here's an example of the numbers that represent the tokens, the words hello world, which is represented by 1,535 numbers. The first three of those look like this. And those have some semantic information within it, so you can find semantically similar, words similar in meaning within this collection of vectors or vector store. This notebook uses OpenAI as the LLM, and it uses a special prompt. Here's a prompt that specifies that it should use these code snippets, which were provided as the documents or digital objects for the RAG. So if you have an environment, please feel free to try this out. It's a quick read, and I think it's very nice. So you might ask yourself, well, if I have RAG to access all the documents, and I have the system prompt that can tell the LLM exactly what I needed to do, why would I need to fine-tune a system? Well, you can do both. You can have a RAG system, and you can also fine-tune it. Usually, fine-tuning will perform better if it's a smaller model that it has been fine-tuned. It can outperform a larger model. You just have to keep in mind that when you fine-tune it, the documents that you give it to learn, the documents that are used for training, can replace some of the patterns that are already there, some of the knowledge that's already there. And that might lead to some catastrophic failure of knowledge. So you have to be aware that when you fine-tune, you're replacing some information for others, and it might lead to unexpected results. So the key to making RAG work, the key to making fine-tuning work is to have a good quality data set. The data set should contain something like the expected input and the expected output, and maybe some kind of validation that somebody already checked that this type of information works. We can explore a lot of data sets within Hugging Face. Hugging Face has a large collection of data sets, and most people that they're developing LLMs use Hugging Face, and a lot of them share their data collections. We could look, for example, for a medical data set. Here I have a data set called Medical O1 Reasoning, or a data set Reasoning Med. These different data sets might have different formats. For example, here I have the instructions and the expected output, and I can navigate the dataset. You can imagine the dataset as just a a collection of a CSV file with inputs, outputs, and some additional metadata. Here it's hard to see because it's too large, but I invite you to review some data sets. Try to find something that might be of interest to you. And here you can see a little hint of what these data sets are used for. They're used to train an LLM. If you have one LLM and you train a certain part of it, we call it fine-tuned. You can train all of it, which is training a model, but it's very resource heavy. If you only train a small part of it, it's called fine-tuning. But it's basically the same training. So in Hugging Face, we can find data sets. Oh, sorry. Different kinds of data sets with some types of descriptions and some content that has been used to train or fine-tune what we call a base model. The model that we use to train on, so we're changing just a small part of it, is called the base model. And then from the base model, we can generate the fine-tuned model. Sometimes these data sets, by the way, it's very important to have high quality data sets because the training, if it's not consistent, the data is not consistent, it will generate a very bad fine-tuned model. Sometimes you might not have enough examples of training data to fine-tune a model. In such a case, you can do some artificial generation of training materials. For example, in InstructLab, you can see they have tools to generate a large set of training data, let's say 100 elements off of 3 elements. So if I were to say that Jacobo Miranda works at EMBL, tries to do cloud computing support, cloud storage, and also training for using cloud technologies, out of that, I can make several sentences like, what does Jacobo Miranda do? It would answer, he works at EMBL. Is there anybody who tries to give cloud technology training? It could answer, Jacobo Miranda does. And you could just artificially generate a set of training data off of a few facts. That can be used to train a model in a very specific task. In InstructLab, they have a very nice animation about what this type of training does. You can imagine the base model as being this complete cube, and it has many facts within it, a lot of knowledge, like these smaller cubes. And if you provided one small new fact and connect it to other information, this is overlapping patterns so that there's no pattern collapse of the retrained data. Once you connect it to other information within the model, you can automatically generate more data from those few facts. And the new data that you generate gets integrated into the base model. So now the base model knows more things or knows things in a better way, or more specifically, it answers your prompts the way that you expect it to. It's like changing the default response of a model. When you fine-tune a model, you don't train it to do something different than it already does. You just change its default response to what you would expect it to do. There's a wonderful video that has an example of how to generate this artificial data from a few examples. And it also has a lot more information about running LLMs. I highly recommend it, but it takes about an hour and a half. In this notebook, we have a commercially available example. This is from Google Colabs, which lets us run a Jupyter notebook in good hardware, this T4. And this Jupyter notebook has been provided by Unsloth, where here they give an example of how to provide training data or generate training data based off of a document. In this notebook, they take a paper about LLMs and they split it up into different sections. And from these sections, they generate question and answer pairs, and then use this question and answer pair to fine tune a model. This notebook contains all the steps, including some things that you have to keep in mind, like cleaning the data or validating that the question and answers are in the correct format. And then it actually does the training in different, it's called epochs, stages. And it has several settings that are briefly described, but at the end, this notebook gives a clear example from beginning to end of how to use your documents and train or fine tune a model. But this is a commercial provider that either costs to run and you're sharing your documents with this infrastructure. If that's not what you want and you want something more private or secure, as I mentioned before, feel free to contact DEKCD. So if you do decide to try this, you can start with a shortcut. There is, in Hugging Face, you can do something called auto-trained models. If I choose a data set, let's say here, this medical LLM 8B, this is not a data set, by the way, this is a model. And I click over here on train, I can use auto train to fine tune this model on a data set that I can provide. Now, this is going to take a little while to set up the environment, but just to give you a little notion, because my time is running out, I'm just going to show you the screens. When I train, at the end, I get an environment that has the most basic requirements to fine tune a model. Here, you can notice that you can provide it your own data set, but you should also set different parameters that I didn't even talk about. But I'm linking to a document that explains what these parameters do. And then I can let Hugging Face infrastructure run the fine tuning to see what type of model it generates. Unfortunately, it doesn't do testing. So you would need to run that fine-tuned model, once again, in Hugging Face and test it with your own data. But this is what I would say a quick start to discovering what it is to fine-tune a model. What you need is your own data set, and you can start with the default settings. Auto-train will try to understand your data and suggest what base model to use. As I mentioned, the base model is the model that's being used as the one that's being adapted or fine-tuned or specialized to generate your fine-tuned model. So there are, in this document, you'll be able to find all these links and information about how to try and do this yourself, and also a link to contact us if you need some help. By the way, I want to thank Robert Hase for a lot of the material that he provided, that he makes available, and like Jupyter notebooks. And I hope that somebody would want to run some of the tutorial Jupyter notebooks that he's provided on the DKCD infrastructure to run the node on DKCD infrastructure if you need to.